My name is Tom. That's my nickname. My full name is Asamoah Kwame. I happen to be an IP network engineer, security engineer, and I'm still learning from top players in the industry. But then I'm really privileged to share this project with you. So some time ago, I used to configure switches using the normal command line. So 50 switches, you configure them. I mean, the stress involved configuring 50 switches, and the most boring thing is if you're configuring the same configurations on these devices. So let's say similar configurations or same configurations across all these devices. So I realized the world is changing, and there's been a lot of changes in the IT industry. Talk about AI and a whole lot of automating of staffs and a lot of things. So that has paved the way for we network engineers who are in the industry. So I realized, no, so why don't I sit down and program a script that can configure certain number of devices, either 50, either 10, just to ease stress from the engineering perspective as a network engineer. So I wrote this script. It's basically 500 lines of codes that will configure some of the basic or some of the advanced configurations an engineer will configure on a collapse core network. And I really hope that you do enjoy this video. It's a project that I've been working on after several weeks and months of testing and troubleshooting just to get everything in place. So in the video, I'll explain every process, every code, what it does, and you will see it relates. I mean, it's just the same as what you do on the command line or on the terminal lines of a switch or a router. The one thing I have learned is that as the world is changing, the IT industry is changing. When you go to data centers, the last one I went to, I realized that nothing has changed with the traditional networking. You still have the RJ45 connecting, you have the switches, the routers, servers connecting in the normal traditional way of doing networking. So I think if you happen to be working somewhere like a data center or any IT infrastructure running these network devices to control your network, I think to be very necessary that you have automation in your system, because at times it can ease stress and save you a lot of time as a network engineer. You just have to write the scripts, you test it, and then you deploy it. So I'm really happy to have you on board, and then I've been watching this video. I'm really privileged, seriously. So I just want you to take a look and then give me a feedback. Feedbacks are very important, and it helps me know what I'm doing, that people do appreciate it. And I really hope, just like somebody inspired me to learn automation, that it will inspire you also to learn automation. And don't worry about all the configurations that's been done behind the scenes before I did this video. I just did this video as a project just to showcase what we can do with automation when it comes to we as network engineers. So I'm really privileged to have you, and I thank you for
and so I'm going to walk you through my network automation project. I have a simple design here, simulating a collapsed core network design. So I have two core switches, and I have these host PCs over here. They are going to receive an IP address from a VLAN on these host switches over here, and I have this switch on top, creating a link for me to connect to core switches, so that when I configure trunk interfaces, it will be able to go through. And I also have a NAT acting as our ISP, providing us with internet. So at the moment, I'm going to walk you through the configurations and then show you what every code does. So first of all, I have two set of codes. I have project, which is the one which is going to push the configurations to our core switches, and I also have this code over here, which is going to back up the entire configuration after we are done pushing the configurations on the switch. And then we also ping google.com and cisco.com just to test if we are able to connect to the Ethernet, because in the main configuration over here, we are going to configure Ethernet connectivity on these core switches. So first of all, I have core switch 1, which means that all this configuration is falling under core switch 1, and as you can see, the indentation over there, and the host is S1. The host is S1 because I have done name resolution over here. So when I type cat sc, shows me the host in my automation machine or my automation PC. So I have S1, which is core switch 1, S2, which is core switch 2 address on my DNS resolving file or config on my Linux PC, which is acting as my network automation host. So as you can see, I can ping S1 and I can also ping S2. So we are good to go. And back to the configurations, and as you can see, this is some variables. Command line storm is the SSH username and password, because Ansible uses SSH to connect to switches. So as you can see, the first task over here is to set up a loopback interface, because we'll be configuring Ospf. So we have the loopback interface set, and we also have a printout acting as a variable which will be registered, and then we will debug the output, which means that after configuring the loopback interface, or after configuring any IP address or configuration on the switches through the Ansible module, we have an output. And the next one is to configure Ospf over here. So we have router 1, router Ospf1, that's the Ospf process, and then I will enable Ospf on all interfaces, and once again I'll debug the output for us to see. And next I'll create VLANs on the core switch. So I'll create a VLAN 10, VLAN 20, VLAN 30, and then VLAN 40. And once again, when I'm done, I will debug the output for console viewing. I also configure change the respective VLANs to their respective name. So VLAN 10 moves to internet, and as you can see the lines here, that's the VLAN 10. So in normal Cisco switch, you type VLAN 10, and within that sub configuration you type Ethernet. So same applies to VLAN 20 over here, same applies to VLAN 30, same applies to VLAN 40, which is bank, same applies to VLAN okay, so here we are setting an SVI for core switch 1 on VLAN 10, and the reason is it's going to distribute dhcp for the host machines, and the core switches is going to do the core switching and everything. So down here I'll configure an IP address for VLAN 10, and once again after configuring I will do a no shutdown to bring the interface up, and I'll also debug the output once again. And here I will enable dhcp on VLAN 10, and on that dhcp pool I'll set the default router to 20.1, which happens to be in the subnet of the dhcp pool, but then I will configure the DNS server to be that of Google. And once again we will debug the output, and there should be exclusion. I mean, you have to exclude certain IP addresses. So 20.1 will be configured on core switch 1, 20.2 will be configured on core switch 2. So the reason why I'm excluding these IP addresses, both and the 254, is for standby protocol. So the reason why I am excluding this IP address range is because let's assume core switch 1 is down, core switch 2 will be in place to act as the DHCP server. So basically I call it DHCP failover protocol, because it acts just like a standby routing protocol. So here too I've configured standby routing protocol, and then when I'm done I'm going to push PC1 into VLAN 10. So as you can see, I have over here interface gigabyte 03, and then the line is switchport access VLAN 10. So once again I'll debug the output, and then when I'm done on so I will bundle gigabyte 01 and then 02 into port aggregation, and then I'll have a track interface is set and the link type set to point, and then I'll create channel group 1, which is creating a port channel interface. And after that, once again, I'll say no shutdown and debug the output. Now, configuring layer 3 port channel. So I'll configure the layer 3 port channel after the channel has been created. I have to configure it, and then I'll set it to trunking.1k encapsulation, and I also have trunk, and then I also have link type point to point for spanning tree, and then I'll say no shutdown, and then once again I'll debug the output. Now when I'm done, I have to do some initial global configuration settings. So the first one is setting the VTP mode to transparent, and also set the spanning tree mode to rapid spanning tree. Then I'll do a port channel load balancing, source destination, a port channel load balancing, source destination IP for VLAN thing, and I also set the IP name server to 88888, and set the IP domain lookup, and then do a static route to my default gateway so that we can get access to the internet. So once again, I'll debug the output. So same configurations being worked out for switch 2 over here, not much of a difference. So configuring OSPF, creating the VLANs on it, same configurations, VLAN 10 to 40 SVI. So as you can see on the exclusion list over here for the dhcp, I have the same thing over here, so that if when core switch 1 goes down, core switch 2 will be acting as a dhcp server and it can perform routing. Right. So once again, I'll debug the output and configure standby routing protocol, and I'll put basic 2 also in VLAN 10, and the output, and then I'll configure port aggregation just like I did for core switch 1, same group for the port aggregation, and then I'll debug the output and I'll perform some global configuration settings on it, IP name server for the switch, IP domain lookup, and then IP route to our default gateway, and once again, so I'll debug the output. So not bad for 487 lines of code. And when we are done, it's very important to copy our running config. So let's say we have 50 switches. How can we copy the running config from all those switches? So without wasting much time, I wrote this simple code. So as you can see, the code says backing up configurations on collapse core switches, which is S1 and then S2. And then down here, I'll say, let me enlarge it small. Okay, so the command is show running config, and then I'll register the variable and debug it to static, and then I'll register the variable and debug it to standard lines. This means that when the configuration is show running config command has been pushed onto the switch, we'll debug it, and then after the debugging, we'll save it to an output on a particular directory on our Linux host, which is acting as our automation device or our automation computer. So when we are done, we need to test for connectivity, because we've tested, we've configured IP route, static route, IP domain lookup, IP name server. So we need to test if we have internet working. So this is my automation. It's a Linux machine. So first of all, I need to create a directory called output. So that's where the configuration files will be kept, a backup of the code. I have the ansible configuration file, and I also have the host. So I'll do a cat host, and as you can see, I have core, and I have S1 and then S2, then I have access. So in my next update, I will include access switches in my topology. So this is just a walkthrough. So what I'm going to do is I'm going to create a file. So I'll say nano try.yml. So I'll go to my switch. I'll go to my text editor, copy all the commands, all the codes, copy, and I'll paste over here, and I'll write, and I'll save. So let's put a timer on it. So I'm going to run the commands on the switches, and you will see how long it takes for this all these configurations to work. So what I'm trying to say is, this is just a sample of what Ansible or automation can do. You can do more than this, but this is just a project, so I'm demonstrating something very small or something very limited for you to see. So Ansible playbook try.yml. So let's keep our timer. 1, 2, 3, let's go. So as you see, it's going to configure the switches. Right, so the first play is setting the loopback interface as we went through in the text editor where the commands were, and now we are doing a live configuration. So as you can see, the output has been debugged. Now we are moving on to Ospf. So interface has been set on core switch 1. Right, so Ospf has been configured on core switch 1, and as you can see, field is false on core switch 1. So we are now changing the names to their respective names: internet, domain, bank, and etc. So it's changing, and I hope you are timing you are timing it. So let's wait and see. So now we are at vlan 40, changing to bank. Right, so we are now moving to setting the SVI for vlan 10. And we are done. So we are next moving to enable dhcp on vlan 10. So the task is to enable dhcp on vlan 10. And the next is to exclude the IP address ranges as I showed you in the text editor. And as you can see, the next one is to configure hot standby routing protocol. Now, so the next is to put host PC1 to vlan 10. So the next is to put host PC1 to vlan 10. Right, so the next is to configure port aggregation on gigabyte 01 and 02. It's taking a while, but surely to go through. So let's be patient. Right, so as you can see, port aggregation has been configured. Now configuring layer 3 port channel. The channel has been created, so it's now configuring it. So we are done. And now moving to the global configuration settings where we have the IP name server and a whole lot of VTP, spanning tree, RSTP. So we are done. We are now moving to core switch 2. So let me show you something on core switch. So as you can see, it has acknowledged that there's a configuration being received. So let's go back to, okay, so we are also enabling Ospf on core switch 2. So once Ospf is enabled on core switch 2, now there should be an adjacency somewhere here. So as you can see, full loading to full loading done. Yes, so we have an adjacency over there. So we are also changing their respective names from vlan 10 or vlan 20 to their respective names. So once you see field is false, that means the codes are working fine. So as I said, I've tested these codes over a period of time and it works so well. This is the power of network automation, and just imagining configuring several number of switches, how automation can help you backing up configuration files. You don't need to work to the switch and a whole lot. You don't need to work to the switch and a whole lot. The world is changing, so it will be very good if we adapt to the new way of automating stuffs. So just as we did for core switch 1, automatically the exclusions has been made. And then we are on putting PC2 into vlan 10. Right, and then we're also configuring port aggregation. Yes, so we are also we are done with the port aggregation. Now configuring the channel that is created. So one is done. You should see that the port channel is up. So let me show you. So the port channel 1 is up on core switch 2. Port channel 1 is up on core switch 1, and then the Ospf is loading to full and loading done. So we have, as you can see, we are done. 30 replace 11 changes, unreachable 0, failed 0, skipped 0, rescued 0, ignored 0. So now let's go back to our core switch 1 and let's see the configurations that we did. So show running config, same on core switch 2, show running config. So back on core switch 1, as you can see, let's go through. So we have the username storm, privilege was 15, password 0, storm. So I configured this username for SSH. So as I said, Ansible uses SSH to talk to network devices. So as you can see, the VTP mode was transparent, and the exclusions that we did for the dhcp, and then the vlan 10 IP address, and then the DNS server we configured, and this was the global configuration that we did. IP domain name is storm engineering that we did. IP domain name is storm engineering.com, IP engineering, and I also have the IP name server over here, and then we have spanning tree mode is rapid spanning tree. As you can see, the VLANs over there, 1020 with their respective names, the interface loopback, and the port aggregation bundled. So we have the link type that I configured. That's the layer 3 configure layer 3 port channel. So that's what we have. And what else can we see? VLAN 1 IP address, which is used for inbound network management. So interface VLAN 10. And so that's the standby routing protocol, and that's all. So I can type show standby, show standby. Okay, show standby something. Can I click it? Yeah, show standby. Yes. So currently, active router is local, and the standby router is 20.2, which happens to be core switch 2. So back on core switch 2, so as you can see, we have the configurations over there. So show standby shows me that this is the standby router for HSRP. And now let's see something, if you can get an IP address on our host PCs. So IP dhcp, can you get an IP address? Yes, of course, you have an IP address. So show IP, as you can see, we've got an IP. Show IP, as you can see, we've got an IP address. So 20.3 from the dhcp pool, 20.1 that's the DNS server, and the gateway is 20.2. Same applies here. Let's see, IP dhcp, can we get an IP address? Of course, we have an IP address. So show IP, so that's the IP address together with the DNS server and the gateway. So back on the switch, so let's say end of the day we are done automating configurations to switches. How do we do? We need to keep a backup of all these configurations. So that's where this code comes in, this very short code. So I'll copy it. So let me create a new file, .yml, and I'll paste in here, write out, exit. So ansible playbook, backup. Last, I'll give a password argument to you for the user. Then I'll use -k to prompt for password. So I'll enter my password for SSH, and let's see if we can back up the configuration files and test a ping to the internet. Remember, I did an IP route, a static route on the core switches, right? So let's see how it goes. Right, so that's the show run. The next task is to save it to a file, and change one is working. So now testing for internet connectivity to the internet. Google.com, Cisco.com. Okay, so as you can see, that's the ping, right? From Cisco.com. Okay, so as you can see, that's the pain, right? So that's the power of automation, and this is a project I've been working on for quite some time and troubleshooting. I really appreciate your time for watching this video, and I'll be hopeful for your feedbacks, and I'll be looking forward to them. So thanks for watching this video, and see you in my